This question is from GATE 2021 Mechanical Engineering paper set 2, question number 52. The wheels and axle system lying on a rough surface is shown in the figure. Each wheel has diameter 0.8 meter and mass 1 kg. Assume that the mass of the wheel is concentrated at rim and neglect the mass of the spokes. The diameter of axle is 0.2 meter and its mass is 1.5 kg. Neglect the moment of inertia of the axle and assume G as 9.8 meter per second square. An effort of 10 Newton is applied on the axle in the horizontal direction shown at midspan of the axle. Assume that the wheels move on a horizontal surface without slip. The acceleration of the wheel's axle system in horizontal direction is dash meter per second square. Round it off to 1 decimal place. Let's find out. So there are two forms of Newton's second law that we have to use here. One is for translational motion, which is summation of forces on the system is equal to mass into acceleration, which is nothing but net force on the system will be equal to the rate of change of momentum, which gives us mass into acceleration. Writing this here, we will have 10 Newton is one force which is in forward direction. So we'll take positive 10. The force that is going to oppose the motion will be the friction force, and friction force should be opposite to the direction of motion. So as this force is applied forward, friction force will apply backwards. It is also given that the surface is rough. Therefore, we have to take friction into account. And therefore 10 minus. Now don't make a mistake of taking only a single friction force value F, because there are two wheels. So 2 points of contact, and therefore we will take minus 2F is equal to total mass of the system is nothing but mass of the wheels, which is 1 kg each. So 2 into 1 plus mass of the axle, which is 1.5 kgs. Into the acceleration A. Acceleration A is the unknown here. The second form of Newton's law of motion is for the rotational motion of wheel. So we have summation of torque on the wheels will be equal to mass moment of inertia of the wheel into alpha, which is angular acceleration of the wheels. So mass moment of inertia for one wheel can be written as mr square, and for two wheels we'll have to multiply this with 2 into angular acceleration can also be written as linear acceleration A upon the radius r, because we know that linear acceleration A is equal to angular acceleration alpha into r. This relationship we have used here just after rearranging. On the left hand side we will have the summation of the torque. Torque is also a result of these forces, 10 Newton and the friction force, because they are not at the center, they are away from the center. So taking moment about center of the wheel, we will have 10 into this distance is 0.1 meter, because it should be half of the diameter of axle. So we have 10 into 0.1 meter, but the moment is anti-clockwise. We take anti-clockwise negative. Moment due to friction will be plus. Now again we have to take for two wheels, so we'll do 2 into the distance of friction force from the center of axle is 0.4 meters. It is given in the other diagram because diameter of the wheel is 0.8 meter. So we take half of it. So it will be 0.4 times F. Now putting the value of mass and radius of the wheel, we will have 0.8 times F minus 1 will be equal to 2 into 1 into A into R. So we have 2 into 0.4 into A. Diameter is 0.8. We have to find out radius and then put it here. Now coming back to the first equation, we'll have from here, we need to find out A. So we can put F in terms of A in the second equation to find out A. So we have from here 2F will be equal to 10 minus 2 plus 1.5 is 3.5. So 10 minus 3.5A, and therefore F will be equal to 5 minus 3.5 by 2 is 1.75 times A. Putting this value of F from 1 into the equation 2, we will have 0.8 times 5 minus 1.75 times A minus 1 is equal to 0.8 times A. Just by rearranging this, we have 4 minus 2.2 times A is equal to 1, and therefore 2.2 times A will be equal to 3. A will be equal to 3 by 2.2, which gives us the answer as 1.363 meter per second square. Let's go back and fill in this answer. So we have to round it off to 1 decimal place, and we have got it as 1.363. So we can round it off to 1.4 meter per second square. To learn more about rotational motion, you can refer to the NPTEL video. Module 7 Lecture 4 Rotational Motion 4. It's from the course Engineering Mechanics. This course is taught by Professor Manoj Harbola. He is from Department of Physics of IIT Kanpur. I hope this solution helps you clear your doubt. Thank you.